Welcome back to the Explainer Focused Learners. Today, we're taking on a topic that honestly strikes fear into the hearts of so many people, but we are going to reframe it completely. I want you to think of a complex, two-dimensional projectile motion problem, not as a stressful math test, but as a video game level. And today, I'm giving you the ultimate cheat codes to conquer it with 100% confidence. By the time we finish this, you'll be able to track, map, and solve for literally any object flying through the air. Okay, let's dive right into this. Here's our level map for the explainer today. First, we've got the projectile challenge, then breaking down components and unlocking the 4 cheat codes. After that, we'll face our mini-bosses, range and max height, before we go head-to-head with the final boss, instantaneous velocity. Number 1, the projectile challenge. Let's set the stage for our scenario. Imagine we are launching a projectile from an 80-meter cliff at a speed of 30 meters per second, angled exactly 30 degrees upward above the horizontal. Our mission here is to track its exact path. Now, to solve this, we need a flawless, overarching strategy. Step 1 is always draw a diagram to visualize that trajectory. Step 2 is breaking our initial launch velocity into separate x and y components. And Step 3 is applying our 4 cheat code equations. Honestly, this simple 3-step roadmap is your key to winning pretty much any projectile problem you'll ever face. Moving on to Section 2, breaking down components. It is time to separate out our x and y axes. Now, what's really interesting about this is the stark dichotomy between the axes. Because we're in 2 dimensions, we split our 30 meter per second launch using a right triangle. We use cosine for the horizontal piece and sine for the vertical piece. But look at how totally different their rules are. In the horizontal x direction, we assume 0 air resistance. Acceleration is 0. The projectile literally just coasts forward. But in the vertical y direction, gravity is the boss. It is constantly pulling downward at a vertical acceleration of negative 9.8 meters per second squared.
All right, Section 3, the 4 cheat codes. Let's adapt our standard kinematic formulas to build our ultimate solving tools.
And this brilliantly illustrates the absolute holy grail of this explainer. You just need these 4 simple equations. On the horizontal x side, displacement is your initial velocity times the cosine of the angle multiplied by time. Horizontal velocity, like we said, it's totally constant. On the vertical y side, your displacement factors in that 80-meter cliff height, the upward launch, and gravity's heavy downward pull. And your vertical velocity drops constantly because gravity is pulling on it. Guys, if you have these 4 codes mapped out, you cannot lose.
Section 4, mini-boss range. Let's face our first hurdle and find out exactly how far this projectile will fly horizontally before smacking into the ground.
So what is the horizontal range? To defeat this mini-boss, we have to think logically. We can't find that horizontal distance until we know exactly how much time the projectile spent in the air, right? So our first move is to find the total flight time. And we do this by looking at our vertical y-axis. When the projectile finally hits the dirt, its vertical position, its y value, is exactly 0. We take our vertical displacement cheat code and just set it to 0. We plug in our 80-meter cliff, our upward launch speed, and gravity. Now, this creates a quadratic equation, but please don't let that word scare you. You just plug those coefficients into a standard calculator or the quadratic formula, and it instantly spits out a flight time of 5.85 seconds. That is exactly how long our object is airborne. Super easy. And now for the finishing move. We take that 5.85 seconds and we plug it straight back into our horizontal displacement cheat code. Initial speed times the cosine of 30 degrees multiplied by 5.85 seconds. The result, a massive 152 meters. That's our horizontal range. Mini-boss defeated. Section 5, mini-boss, max height. Let's find out how high this projectile arced into the sky. Specifically, we want to know the maximum height it reached above the 80-meter cliff. To defeat this stage, you need to understand one absolutely crucial physics trick. Think about throwing a baseball straight up in the air. At the absolute highest point of its arc, right before it gives up and starts falling back down, it actually stops moving vertically for a tiny fraction of a second. Its vertical velocity becomes exactly 0. So the crucial point is we take our vertical velocity cheat code and set it to 0. When we solve for time, we get 1.53 seconds to reach the absolute top. Then we plug that 1.53 seconds into our vertical displacement code, crunch the math, and we find the total vertical position is 91.48 meters from the ground. But wait, remember the exact question? We wanted the maximum height above the cliff.
Since our total height from the ground is 91.48 meters, and our cliff was 80 meters high to begin with, we just subtract the cliff. The projectile rose exactly 11.48 meters above the edge of the cliff. Boom! Second mini-boss defeated with total ease.
Let's move to Section 6 and see how this all builds to the final boss, velocity. We've mastered distance and height. Now, let's calculate the instantaneous velocity.
What is the exact total velocity of the projectile at precisely the 3-second mark? To win this final stage, we can't just plug a number into one magic equation. We have to look at our horizontal and vertical velocity cheat codes completely independently. We need to find how fast it's moving forward and how fast it's moving downward at that exact second in time.
On the horizontal x side, it's a breeze. Remember our golden rule? Horizontal velocity never changes. So Vx is simply our launch speed times cosine 30. It is a steady, constant 26 meters per second. But on the vertical y side, gravity has been doing its thing for 3 whole seconds. When we plug 3 seconds into our vertical velocity code, we get negative 14.4 meters per second. That negative sign is absolutely critical. It means the projectile has already crested its arc and is actively falling downward. To get the total overall velocity, we need to combine these two pieces together. Imagine forming another right triangle. The constant forward velocity of 26 is one side, and the downward falling velocity of negative 14.4 is the other. To find the total velocity, we just need the hypotenuse. So we call on our old friend the Pythagorean theorem. A squared plus b squared equals c squared.
We square 26, we square negative 14.4, add them up, and take the square root. The result? The projectile is moving at a total speed of nearly 30, actually exactly 29.72 meters per second. And if you want to find the angle of that drop, use a quick inverse tangent function on our triangle, revealing it's angled at exactly 29 degrees below the horizontal. Final boss, officially defeated.
Congratulations! We drew the map, we broke down the components, and we used 4 simple cheat codes to perfectly predict reality. Every thrown ball, every leaping athlete, every single drop of water from a hose follows these exact same codes. So, I leave you with this. If you can decode the hidden mathematics of a soaring projectile, what other hidden rules of the universe are just waiting for you to unlock them? Keep visualizing, stay curious, and I'll see you on the next level.